Hello and welcome to my YouTube channel Technocrats. In today's video we will learn about the Omron PLC Modbus communication with Omron VFD 3G3MV inverter. So PLC used here is CP1E. As CP1E does not have a built-in RS485 communication port, so we will be using CP1W-CIF11 On board card. So let's get started. Here I will open CX Programmer. Now we will select the PLC, CP1E, and 40 is set as default. OK. So basic, first of all, what you have to do is you have to go to the setting, serial option port. You will select mode as Modbus RTU simple master, and I am using standard like baud rate is 9600.172 and even. So you can use custom also if you require. So I will use standard here. That's all in the setting part. Now let's move to the program section. In the program section, first I will show you the manual. In the manual, if we talk about CP1E and 30 and 40 and S1 or N8 CPU unit with a serial optional port built-in 485. So we have D1300 as our starting register, that is for slave address. Now 1301 is for function code, 1302 is for number of communication data bytes, 321349 is for your communication data. That includes your Modbus address, the number of bytes you want to send or receive, and etc. So let's move to the programming section now. So I will write P underscore first cycle. So initially we will initialize all the data register like 1306, 1307 and your Modbus polling bit, that is A61.0, and 01 is for your feedback. So we will reset A61.4 whole your data area. So let's start. IMOV first. We can use a #0 and D1306. Now IMOV D-0 D1307, and we will also reset the polling bit of Modbus, that is A641. Now we will write IMOV #0 A641. Okay, this is your Modbus. You can say Modbus RTU master start bit. Now start bit is your A61.0. Now once the initialize is over, we will move to the programming section. So let me write W. We can use P underscore on. Okay. Like IMOV. I am using one as your slave station, D1300. It is your slave ID of your inverter or any another device you are using. So I will use for slave ID. Now the next one is your function code. So for function code IMOV, and the function code we can put at #10 D1302. This is your function code. Now another one. Now we will write 1303 is your 1302 is your communication data byte. So in communication data byte we will use #9 1303 your communication byte. Now 1304 is your number of register to be written, so I will use #2. So here we will give the start command and the frequency to the drive. So this is only we are using start command and we are using the frequency, we are writing the frequency. So start command frequency is written only YMOV. Now 1305 is for data size in bytes. So how much bytes we are sending to the controller. So we are using here 4 bytes. So we use #4 and D1305. This is your data size in bytes. Okay. Now after this 1306 till now, this is your main part. This is always, I use always on here. Now we will use the commands like W0.00 is your start command to drive, start CMD @ हम कितनी frequency दे रहे हैं सबसे पहले, sorry, how much frequency we are transferring is initially is 40 Hz. So we use 40 Hz. Okay, I'm just comment, this is only the comment section. Now what I will use is IMOV hash. We can use let me open the calculator first. So in the first data word, that is your 1306, the first 2 will be your run command, that is 01 is your run command. Okay, now we have to also write the frequency. So I am using 40 Hz, so that will be 40 and 00, 2 more 0 will be added. So the hex code is FA0. FA0 is a hex code. So I will write here #01 is your start command for drive. Forgotten what was that calculator. 40,000 FA. Okay, so I will use FA here, D1306. Okay, with this, the second part of your frequency, that was IMOV. Now it is I think a D1307. Okay. #0, sorry. So this is your start command @ of frequency is 40 Hz. Now if I want to increase the speed, let me use W0.01. Start @ speed of let's suppose we can use 50 Hz. Okay, so again I will just copy this section. In the place of FA0, we will just use calculator. We will use here 50 Hz. So 1388 is your hex code, so I will use 13. Okay, the other part is 88. I will use 8800. Okay, so this is how you can write your start command frequency. And if you want to stop this drive and also stop the also reduce the frequency to 0, so you can W0.02. okay, control V, and you can use your 000. Okay, and again here 0. Okay, shuffle. So this will stop the stop command at 0 Hz. Frequency will also reduce to 0. So after this, you have to use p underscore sorry 1 second pulse can be used here. Now to the rising edge of this, we have to use it. You can use timer also, or you can use this p underscore 1 second pulse to set the bit function. Set the bit A641.0, that is your Modbus RTU start bit. Okay, Modbus RTU master start bit, or you can also set it by A641.01, sorry, A641.01. this is your master execution normal flag. Okay, so that's all. So that's all in this video. This is the whole program. I will provide you the link of this sample program in description. So if you want to download this sample, you can download it from there. And if you like my video, please like, share and subscribe. Thank you.